Bismillahirrahmanirrahim. Wassalamu ala Rasulillah sallallahu alayhi wa sallam. Today we are going to follow or continue studying the probability as we have stopped at the probability of events. So the probability of events, as we have mentioned before, that if you want to find the probability, for example, find the probability of getting odd number when throwing a dice once. What's the probability of getting odd number when throwing a dice once? So first, what is the sample space of throwing a dice once? Sample space equals 1, 2, 3, 4, 5, and 6. This is all the faces of dice. The event A, for example, is the event of getting odd numbers. What are the odd numbers that may appear in the upper face of the dice? 1, 3, and 5. This is the odd numbers that may appear on the upper face of the dice. 1, 3, and 5. Now, we want to find the probability of getting odd number, probability of event A equals, as the rule mentioned, that we divide the number of elements of A divides the number of samples. The number of elements of A is 1, 2, 3, over the total number of sample space is 1, 2, 3, 4, 5, 6. Okay, this is we have finished this last time. Also, what is the sum of all probabilities of an experiment? As we have mentioned, equals 1. Why? For example, we'll take an example of probability of getting head. What is the probability of getting head when throwing a coin once? The probability of getting it. How many heads on the coin? 1. How many faces of the coin? 2. Probability of getting tail is the same, because how many tails? 1. How many faces of dice? 2. If we add them, probability of getting head plus probability of getting tail equals half plus half equals 1. So the sum of all probabilities of an experiment equals 1. This is a rule. Okay. The probability, this is another 1. The probability of non-occurrence of an event A equals 1, which is the sum of or the probability of sure event minus the probability of the occurrence of the event A. Or we can write it as probability of the complement of A. This means complement of A, which is the probability of non-occurrence of event. So non-occurrence of A is A dash, okay, equals 1 minus probability of A itself. Like what? For example, if the probability of success of a student equals 0.8, then the probability of his failure, the probability of success is 0.8, and the probability of his failure. So this is the probability of non-occurrence of an event, which is probability of A dash, non-occurrence of the event, equals 1 minus probability of A equals 1 minus 0.8 equals 0.2. First problem, the question says, in an experiment, selecting a card at random from 7 equal cards numbered from 1 to 7. So the cards numbered from 1 to 7. Write the sample space first. The first required to find the sample space, then find sample space is required first, then find the probability of event A, B, C. Okay. First, we have to find sample space. So the sample space is, we have 7 cards numbered from 1 to 7. So we have to write the sample space from 1 to 7. 1, 2, 3, 4, 5, 6, and 7. Okay. Okay. Number 2, the event. This is the first question. The event A, where A is appearing a number less than 4. less than 4. So what are the numbers? The numbers that are less than 4 exist here. These numbers are less than 4. So event A equals 1, 2, 3, and 4 is not included. 4 is not included because there is no equal, as you know. So the probability, the required is the probability of, not the event itself, but the probability, as we can find the probability of A equals the number of the elements of the event A, 1, 2, 3, over the total number of sample space, 1, 2, 3, 4, 5, 6, and 7. Okay, 3 over 7. So this is the first required. Second required, event B. What is the required in event B? The event B where appearance of an odd number. What are the odd numbers in the sample space? Odd numbers are 1, 3, 5, and 7. Okay, 1, 3, 5, and 7. This is the odd numbers. The probability of B equals count 1, 2, 3, 4, 4 over the total number of sample space 1, 2, 3, 4, 5, 6, 7 over 7. Okay. The third required is C. The event C, where C is appearing the number more than 5. More than 5. What are the number more than 5 or greater than 5 or 6 and 7? 6 and 7. And this probability of C. The next problem is the experiment of tossing a regular die once and observing the number of dots on the upper face finds the probability of. So first we have to write the sample space. So let this A and this B. So is the A is the event of appearance of the number less than 5. So the sample space first of throwing the dice once, 1, 2, 3, 4, 5, or 6. Okay, so the event A is appearing of a number less than 5. What are the number less than 5? 1, 2, 3, 4, and 5. Okay. 5 is not included also. There is no equal. Okay, so 5 is not included. Okay. Okay. So next, so what is the probability of getting a number less than 5? How many elements of the event A? 1, 2, 3, 4. So 4 over the total number of sample space, which is 6. You can simplify by dividing by 2. 4 divided by 2 equals 2. 6 divided by 2 equals 3. So the second required is B, event B, where B is the event of appearance of a number satisfy the inequality B greater than or equals to 3. What are the numbers which are greater than 3, 4, 5, and 6? But there is equal here. This is equal. So by 3 is included. So 3 is included. 3, 4, 5, 6. Now the probability of B equals 1, 2, 3, 4. 4 over 6. Over 4. 1, 2, 3. Sorry. 4 over the total number of sample space equal over 6. Equals by simplifying by dividing by 2. So it will be 2/3. Okay. So this is the second required. Okay. The next one, a box contains 8 white balls, 12 red balls. All of them are symmetric. A ball is selected without looking. Without looking means that random. Okay. Find the following probabilities. Okay, you have 8 white and 12 red, so you have to find the total number of balls. So total number of balls equals 8 plus 12 equals 20 balls. This is the total number. Now find the selected ball is white. or the probability of the selected ball is 1. So the probability of getting white ball equals the number of white balls is 8 over the total number of balls equals 20 by dividing by 4. 8 divided by 4 is 2. 20 divided by 4 is 5. 2/5. Okay? You can simplify. Okay? What is the probability of getting red? Probability of getting red. Probability of getting red ball or selecting a red ball. What is the number of red balls? Or 12 over the total number of balls is 20 by dividing by 4. 12 divided by 4 is 3. 20 divided by 4 is 5. Okay? So this is the probability of getting red ball. What is the probability of the selected ball is blue? Is there any blue here? No blue balls. So this event is 5. So the probability of getting blue equal 0 because, okay? So let's start. Let's start. A class contains 20 boys and 15 girls. If a pupil is selected or chosen at random, then the probability that the pupil is a boy. The probability of getting a boy is a selected pupil is a boy. First, as we have mentioned, we have to find the total number of pupils. So the total number of pupils equals 20 plus 15 equals 35. Okay, this is the total number of pupils. Now, the selected one is a boy. So we will divide the number of boys over the total number. So the probability of getting a boy equals the number of boys, which is 20 over 35. Dividing by 5, 4 over 7. Okay? This is the probability of getting a boy. Next problem, a letter is selected at random from the name As-Salam. The name As-Salam. The probability of selecting a letter A, so the probability of getting a letter A equal the number of letters A, 1, 2, 3. So 3 over the total number of letters 1, 2, 3, 4, 5, 6, 7. 3 over 7. Okay. The probability of impossible event, as we have mentioned before, equals 0. Okay. The probability of the sum of all outcomes of a random experiment, as we have mentioned, also equals 1. Okay. The probability of success is 0.8. Then the probability of failure, as we have mentioned, the event and its complement, we will subtract from 1. 1 minus 0.8 equals 0.2. Okay? As throwing a die once, the probability of getting a number divisible by 7. Divisible by 7. What are the numbers on the dice divisible by 7? What are the numbers on the dice that are divisible on 7? There is no element which is divisible by 7 on the dice. ما فيش أي عدد فيهم divisible by 7, so the answer is 0. The answer is 0. This is an impossible event. This is an impossible event. A box contains 5 red, 3 blue, 2 yellow balls. Then the probability of getting red. First, we have to find the total number of balls. So the total number equals 5 plus 3 plus 2 equals 5 plus 3 is 8, 8 plus 2 is 10. 10 balls. Now we can find the probability of getting red equals the number of red balls is 5. 5 over 10. You can now simplify by dividing by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. So this is the probability of getting red. Okay? Okay. So next, choose the correct answer. If an experiment of tossing a metal coin once, probability of getting head. The probability of appearing head. So probability of appearing head. How many heads can be appear on the upper face of the coin? 1. Over the total number of faces. How many faces on the coin? 2. So the probability of getting it is half. The probability of getting it is half. Also, the probability of getting tail is half also. 1 tail over 2 faces. Okay. A letter, number 2, a letter is selected at random from the word prime. Then the probability of selecting the letter M. What's the probability of selecting the letter M? So, how many M's in the word prime? 1, only 1. The probability of getting M. Probability of getting M. Okay. The probability of getting M equals, how many M's in the word prime is 1 over the total number of letters 1, 2, 3, 4, 5 over 5. Okay. The probability of getting M. So this is 1 over students. 32 of them are succeed in the test. Then the probability of fail. Probability of fail. First, we have to find the number of failed students. There is 2 ways, but I will select this way. Failure students or failed students equals 40 minus the total number of students minus the number of succeeded students minus 32 equals 8 students. Now we can find the failure students, the probability of failed students equals the number of failed students 8 over the total number, which is 40 by dividing by 8 is 1 over 45 by 8 is 5. So the result will be 1 over 5. Okay. The next one, the probability of winning a game is 0.8. This is the probability of losing. So probability of losing. This is, as we have mentioned before, a complement event and its complement, which is subtracting from 1 minus 0.8 equals 0.2. Okay, repeat it. If a die is tossed once, then the probability of getting a number satisfying the inequality. X greater than 5 and smaller than 6. Smaller than 6. Okay, is there any fraction on the dice? X greater than 5 and smaller than 6 means there is a fraction. Is there any fraction on the dice? No, the sample space of the dice says that the numbers are 1, 2, 3, 4, 5, and 6. There is no fractions. There is no fraction. So this is impossible event since this probability equals 0. Equals 0 because there is no fraction lies between 5 and 0 lies or exists on the faces of the dice. So the probability equals 0. A card is selected at random from the bag, from a bag numbered from 1 to 25. Calculate the probability that the drawn card is a number divisible by 5. What are the numbers from 1 to 25 are divisible by 5? So the numbers which are divisible by 5 are 5, which are the units. Its unit is 0 and 5 is divisible by 5. So 5, 10, 15, 20, and 25. These numbers are all divisible by 5. Now we can find the probability of a number divisible by 5. So this is A and this is B. So the probability of A event equals the number of this event 1, 2, 3, 4, 5. 5 over the total number of cards is 25. Total number of cards is 25. Now you can simplify by dividing by 5. Dividing by 5. 5 divided by 5 is 1. 25 divided by 5 is 5. So the result is 1 over 5. Perfect square. Perfect square. What are the perfect square exist between the two numbers 1 to 25? The perfect square is the number that we can find number multiplied by itself to get this number. This is called a perfect square. Like what? Like 1. 1 is 1 times 1. 1 equals 1 times 1. So 1 is perfect square. Also 4 equals 2 times 2. So 4 is perfect square. Okay? 4. 9 is perfect square because 9 equals 3 times 3. Okay? So 9. Also 10 equals 2 times 5. So it is not. It's not perfect square. Also 16 because 16 equals 4 times 4. 25 also is a perfect square because it's 5 times 5. So these numbers are called perfect square. 1, 2, 3, 4, 5. So the probability of D equals the total number. This number is 5 over 25. By simplifying, by dividing by 5 is 1 over 5. Okay? So this is the second required. Okay? The second problem, a box contains, if a box contains 5 red, 8 blue, 3 yellow, 4 black, find the probability that the ball is red. So first we have to find the total number of balls. 5 plus 8 plus 3 plus 4 equals 20. Now we can find the probability of getting red equals how many red balls? 5. 5 over 20. You can simplify, it will be 1 over 4. Probability of green, green is 8. 8 over 20, dividing by 4, 2 over 5. Not black. Not black means yellow, green, and red. So we'll add them all. Or add them all. So 8 plus 8 is 16 over 20 equals 4 over 5. Okay? The last problem, if a dice is tossed, then find the probability of getting a number, let this A and this B. Probability of getting a number satisfies the inequality when throwing a coin, a dice, sorry. So there is no fraction in the dice, so the probability of x greater than 2 and smaller than 3 equals 0. Also getting a number divisible by 3. So B equals what are the numbers on the dice that are divisible by 3? These numbers are 3 and 6. This number. So the probability of B equals 1, 2, 2 over 6. You can simplify by dividing by 2, 1 over